So let's talk about a formal lab report and how you would write that. And please note, I strongly suggest that you handwrite reports, or at least the outline of reports, in your lab notebook. That's your permanent record, before you come to the keyboard and start keying in your lab report. But just looking here at our Unit 1 Learning Guide for Atomic Structure and Properties, if you'll go to the bottom of the first page, you see this link, Lab Report Template Formal. And what we'll do here is we will click on that, and we will click on the template. I'm going to go ahead and have it fill the page so you can watch what I'm doing and perhaps get that up on your own computer while you're listening to this video. Now you'll notice this is a template for writing up a chemistry lab report, and I have given you the instructions, and please do it, to delete all this shaded text before you submit. So we've got lab report, and then you're going to type in a title for the investigation here. What will it be? Well, in some cases we do a stoichiometry of carbonates. And now notice I am going to delete this gray text, and it's right there. You're going to put your name, the date of the experiment, and if it's relevant, the period in which you are doing the experiment. All right. There are two critical things in every experiment that you must make sure you do it carefully. The objective is on this first page, and it is stated either as a question or as a statement. And for instance, quantify the relationship between the pressure, volume, and temperature of an enclosed gas. So you're going to see quantities, measurements in the experiment, and hopefully by the end of the work that you do, and the end of what we're going to show you here, you will have some sort of formula, mathematical formula, relating pressure, volume, and temperature. All right, that's the most important thing on the first page. On the back page is your conclusion. And here you're going to answer the question you raised in the objective. You'll make a claim and support it logically with evidence developed in the experiment, in the data, in the calculations, whatever. And most of the time, you can make conclusions in 2 sentences. All right? Now, and by the way, I like the experiment is not a conclusion. Don't try it here, don't try it in college. It just looks silly. That's nice for a 3rd grade report, but not in high school or college. Finally, this is an optional section, commentary and extensions. You're going to have something in here in most reports. If you had a systematic error, like the thermometers weren't calibrated, or the balance consistently read 0.1 grams too much, you're going to discuss any systematic errors, although when relative balance measurements are used, that usually doesn't make a big deal. But if it does, you should discuss any sources of systematic error. And then factors that might influence random error. For instance, the temperature drastically changed during the course of the experiment. That might have an effect. Maybe the temperature went up and down, or a big storm blew through and messed up the barometric pressure. And then if your experiment leads you to ask other questions, you would add them here. That helps you to move forward if the instructor thinks you should investigate those questions that arose during the experiment. All right, let's go back up to the first page. Now, here you have materials and procedure. Now, if you are doing step by step exactly what's in a published protocol, then you'll reference that chapter and verse, what book or what article it was from, where it was from, when it was published, and so forth. The usual, perhaps MLA format of a reference. And if you made any modifications to it, you would indicate that here. If you're working with chemicals, this is where you will have a separate paragraph, and you would look at the SDS on that chemical and tell us what hazards there were and how you managed those hazards. So materials and procedure, an important part. Qualitative data may or may not be important in a given experiment. So qualitative data, you're going to talk about colors that you might have seen, textures of substances, odors, if you're careful, of course, and indicating what those are and finding out what the smell is like. So here, qualitative data that's relevant. Make sure it's relevant to your objective. Next, you have quantitative data. Now, notice, this might be pressure and temperature, or pressure and volume. It might be, here you might have mass initial, mass final. But these are going to have numbers in them. Now, the unit will be put up on top, usually in parentheses. So cubic centimeters, degrees Celsius, whatever it might be, would go up here. And then the only thing you would have in your table is a series of numbers, not 52.6 centimeters. No. The centimeter unit would be on top. That way, it's a lot easier to spreadsheet what you have down here if you need to do calculations. If you're ending up doing 60 or 70 calculations of the same kind, a spreadsheet is a very useful thing for you to use. Now, how many headings there are, how many columns there are, it just depends on the lab. So I put 3 here so you could see there may be more than 2, there may be 4. It depends on what you're measuring. Next, you will show calculations. For instance, if you calculate pressure times temperature, or pressure times volume, or mass divided by volume to get density, you're going to show one example, just one, of every calculation you did in order to prepare for your conclusion. Make sure you have a unit with every measurement that you are putting in here, and the various word processing programs you use, including Google Docs, will give you an equation editor. Words tends to be very, very powerful. I recommend that to be used, or WordPerfect or whatever, but don't show your calculations, especially with slashes for division. Show the horizontal bar for the division if you're doing a division. And then you're going to show how you did every calculation. Next, this also is a section where you put graphs. Once you've done your calculations, you're going to graph any relevant data or relevant results. You'll graph them here. Sometimes if you're graphing results like densities versus, say, temperature, you might want to put those graphs after the results, because here you're going to present the logic that connects your graphs and calculations and conclusion together. Generally speaking, we'll have a table of results here. For instance, temperature and density. Now, temperature is probably data. Temperature change would be a calculation, which would come from here. But this is generally manipulated data, results in a table that if you're going to produce a graph, then that graph would follow so we could see where the numbers for your graph came from. They come either from data or from results. And you want to perhaps write here also logically how you got from here to your conclusion. We've talked about the conclusion before, but you see the kind of evidence that the conclusion is supported by is going to be right up here in the body of the report. I hope this is helpful to you, and please ask questions if you have any.